All right, the first one was a heat transfer question. And this one was about one of those composite wall problems that we've probably all seen a few of in our travels, depending on how far along you are. Practice exam one, number 42. I tried solving the problem using the formula found in the reference handbook on page 287. The formula finds the temperature at any interface location X by using R total, Rx, T inside, and T outside. I got the same R total as you did, but I got Tx, the temperature at location X, as 66 degrees. Am I not following the equation correctly? Yeah, you're not. And I'll explain why. But I guess my broader point here is I would invite you to, I don't want to say ignore this equation, but check out the solution video I did on this one and try to follow it and keep your intuition turned on at every step in the process because this situation, let me just draw it, a quick sketch of what we had. We had the insulation was in the middle, so there was brick on the outside, and then insulation in the middle, and then gypsum board on the inside. And there was some inside temperature. I think I gave the surface temperatures in the problem. So some known surface temperature of 70 degrees, and then outside surface temperature of 0 degrees, so very cold. And the correct answer at this interface was, I think I had labeled it in the problem as A, B, C, D. But if you want to use that formula, they're calling it the temperature at location X. So I guess what I called B would be X. So the location at B, or X, turned out to be 4 degrees. So if you calculated that it was 66 degrees, kind of have to ask yourself, does that make sense, seeing as that's on the other side of the insulation? So it's warm inside, cold outside. The brick is not a great insulator. The gypsum board is better, but it's not as thick. Neither one of them have really excellent insulating properties. So they're more or less going to have the same, not same, but similar temperature on either side of those layers as the other side. So if this is 0, there's no way this is going to be 66. This could be 66. This is more likely to be much closer to 0. There's going to be a huge thermal gradient, a big delta T across the insulation, because the insulation by design has great insulating properties. So that's the big idea. And in the problem, I stepped through it sequentially, and at some point I set up a proportion, which is really what this equation is doing. So if you're going to use this equation, you kind of can't just turn your brain off and say, all right, let me plug in all the variables and it cranks out the answer. If you do, you do that at your own peril. But I do know where you went wrong on this one, and I'll share where I think that happened. So in that equation, you said you found R total and you got that right. That was 14.3 in the problem. But then Rx, what is Rx? You kind of have two choices. Rx could either be, so if R total is the total resistance across all 3 layers, then Rx either has to be this resistance, just the brick, or this resistance, insulation plus the gypsum. It's partial, but the question is which part? And you chose this part for the brick, thinking, I know the resistance of the brick, and when you do that, you get temperature at B equals 66. It makes no sense. So what you have to do instead is make this your Rx, which is not intuitive. So you have to take R total, Rx then, equals R total minus the resistance of the brick, which is the same as the resistance of the insulation plus the resistance of the gypsum. This isn't a formula that you'll find anywhere. This is not written in the reference handbook. You have to think about this, or you have to just trust the equation and then use your engineering judgment when you get the answer and see if it's reasonable. And in your case, I mean, you're asking the question, so I think your engineering judgment is good here. You're like, hey, hang on a minute, this can't be 66. I don't think you had to check the answer to see if that was reasonable. Probably warning bells were going off in your head. This can't be. And if that's the case, that's good. And then the question is, how do we circle back and make this work? And the answer is the Rx value is the balance of the resistance provided by the wall in its entirety minus what's provided by the brick. It's everything else. And I could go into a lot more about like why that is, but I think just watch the solution video again with an open mind to kind of seeing when I apply that proportion, where is that coming from? And I think that'll probably close the loop for you. Yeah, I think that's all I have on that one.